Good day everyone. Here we are at EE 323 Renewable Energy, presenting to you our group, the Uncanny Counter. My name is Karen Joy B. SERAFICA as a hustler, Tom A. Castillo as a hacker, and DEZYLYN G. MATEO as a hipster. Looking back on our last video, we tackled the types of renewable energy resources: the solar energy, the wind energy, the hydrogen energy, hydro energy, geothermal energy, and last is the bioenergy. Diba sa last video natin, tinalakay natin yung ocean energy. And now, we will go for solar energy. Brief introduction to you, the largest photovoltaic power station. Unang-una na rito is the Badla Solar Park, which is located at India with 2,245 capacity megawatts. Sumunod dito yung Huanghe Hydropower Golmud Solar Park in China with 2,200 megawatts. Next is Fagada Solar Park located at India with 2,050 capacity megawatts. Next is the Benban Solar Park in Egypt with 1,650 capacity megawatts. And last is the Tengar Desert Solar Park with 1,547 capacity megawatts. So kung mapapansin natin, yung year na to ay parang latest lang, which is latest talaga. Yung India naman, kung mapapansin nyo sa India, ito ay na-built noong 2020 lang. Next, in China rin 2020, yung India 2019, next sa Egypt 2019, and last is 2016 naman. So here is the figure or example photo of Badla Solar Power Park in India. Diba sobrang daming solar power. Next, solar power plant in Philippines. The Calatagan Solar Farm is a 63.3 megawatts solar power plant in Calatagan, Batangas owned by Solar Philippines. Yung Calatagan Solar Farm ay matatagpuan daw sa Calatagan, Batangas. Next, it was reported that the groundbreaking for the solar facility was done, which cost 5.7 billion. The facility was built by 2,500 people in 160 hectares land near the foot of Mount San Pedro. Upon its completion, the solar farm 200,000 panels. Majority of the funds for the project's cost was shouldered by the Philippines Business Bank, Banco de Oro, China Bank, and the Bank of the Commerce also provided funds. By the end of February, the Calatagan Solar Farm is already generating power weeks before the deadline set by the Department of Energy of March 15, 2016. Sabi pa dito sa note, Ilijan Combined Cycle Power Plant and Small Power Station is the largest in the Philippines with generating capacity of 120 megawatts. Luzon Grid has a total capacity of 14,348 megawatts. Three Gorges Dam in China has capacity of 22,500 megawatts. Kung mapapansin nyo, sa India, meron siyang 2,245 megawatts, largest photovoltaic na to. And sa Philippines, meron siyang 120 megawatts. So here is the figure of Ilijan Combined Cycle Power Plant with 120 megawatts capacity. So, how do solar power plant work? Solar power plant use the sun rays to produce electricity. It has too many types: ang photovoltaic plants and the solar thermal system. Sa photovoltaic plants, this type uses the energy from the sun and converts it into electricity using a solar cell. Dito sa photovoltaic plants, ang nangyari dito yung ginagamit niya yung energy mula sa init ng araw and convert it into electricity, kung saan gagamit ka ng solar cell. Next naman is the solar thermal system, or kilala din siya ang solar power plant, pero magkaiba siya ng operation. Solar thermal power plants utilize energy from the sun to heat up fluid to a high temperature. This fluid then transfers its heat to water, which then becomes superheated steam. The pressure from the steam cools the turbine to turn. Dito sa solar thermal system, ginagamit or utilize nito yung energy mula sa sun to give heat to fluids. Tapos pag nag-init na yung fluid with a high temperature, isasalin nito yung heat sa water. And yung water na yung mag-heat and magkakos ito ng steam. Yung steam na mangyayari, yun yung magbibigay ng or magpuproduce ng electricity. Sabi dito, the pressure from the steam cause the turbine to turn. So, how do solar power cell looks like? So, meron akong papakita sa inyo na dalawang types ng solar power. Isang, mapapansin niyo dito yung kulay. Yung solar power cell ay kulay black. Ito naman ay kulay blue. So, ano ba pagkakaiba ng dalawa na to? Yung black solar power cell, it is made up by monocrystalline silicon solar cell. And the blue color of solar power cell is made up by polycrystalline silicon solar cell. So, this is the typical solar power cell built in a house. So, to give you a brief knowledge about solar power, here are some parts of solar power. How do solar power cell looks like? To answer this question, let us study first the components of a solar cell. Unang-una na dito is the aluminum frame, tempered glass, encapsulant, solar cells, encapsulant, backsheet, and the last is the junction box.
To be specific, these are the layers of a solar cell. It consists of glass, anti-reflection coating, metal grid, silicon, which consists of N-type and P-type. At sa gitna nun, doon natin makikita yung depletion region. Then last is yung metal plate na directly connect sa P-type ng silicon junction. So simulan na natin sagutin yung tanong na, how do solar cell work? Let us start on the first thing that is happening inside the solar cell when sunlight strikes it. For maximum efficiency to occur, the solar panel must absorb as many energy as it can from the sun. The more energy it absorbs, the more energy can supply. So directly proportional sila. Pag maraming energy na nakuha kami from the sun, marami ding ma-generate na energy. Here's the thing. Somewhere around 5% of energy from the sun is already lost due to the reflection once it hit the glass, which is the top layer. So, pag yung sun rays tumama sa glass, meron ng around 5% ng energy ang mawawala dahil sa deflection. To avoid further losses of sun's energy upon entering the glass, this is where the anti-reflection coating comes into play. So sa anti-reflection coating, meron tayong mga scenario to be avoided to prevent losses due to reflection. So isa to sa mga scenario na kailangan natin ma-avoid. So dito, yung sun rays tumama sa glass on the top, may penetrate siya sa bottom. Then magkakaroon ng reflection coming from the bottom. Ngayon, if it is in proper synchronization with the rays being reflected on top, hindi lahat mag-goes back to the system. Kasi may mga reflected rays goes through the glass na nag-escape sa system. So, kailangan nating ma-avoid siya. So, ito pa isang scenario na kailangan nating ma-avoid na kapag not perfect synchronization sila. With the right amount of coating, the reflected energy can be minimized if not totally cancelled. So, dapat tama yung thickness ng coating. So, mapapansin natin dito na yung reflected rays goes back to the system. Anti-reflection coating lets the light in, but mostly, it doesn't let the light to be reflected out. It also makes some of the reflected light to get back. Certain manipulation is being done during manufacturing to achieve that characteristics. Maybe some of you will ask, what if just let the light strike silicon junction without any barriers on top? So bakit hindi na lang natin tanggalin yung mga layers on the top, then lets the sunlight directly hits the silicon junction? The silicon, being a semiconductor, is a bit shiny. Exposing it directly to sunlight may lose about 30% of sun's energy due to reflection.
The question is, why metal plate is not a grade 1? It's because of rigid. Because if it's grid, the sunlight will be refract which could not produce electricity. So now, here is the question. What's the main thing that is happening inside a solar cell or photovoltaic cell? That is why it is able to produce electricity when sunlight strikes it. So, let us first define what is photovoltaic effect. The photovoltaic effect is the generation of voltage and electric current in a material upon exposure to light. It is a physical and chemical phenomenon. Here are the three main forms of energy from sun. The first one is the ultraviolet ray, the visible light, and the infrared ray. To achieve the photovoltaic effect, we need a material which when struck by sunlight will exhibit some characteristic of conductor. So we have here a few questions. What is happening inside a copper conductor then there is no presence of voltage across it? So here is the answer. Its valence electron is free to move, transferring from one atom to another atom in random. So, that particular characteristic of a conductor where there are number of electrons that moves freely is what should be attained to exhibit the photovoltaic effect. This is where the silicon semiconductor comes into play. When the silicon semiconductor absorbs energy from the sun, the photons which the sunlight have could knock an electron out of its orbit within an atom, making it free to move within the system in random. So, among the three main forms of energy from the sun, only the visible light contains the photons.
So now, this is the lattice structure of silicon atom forming a covalent band with four neighboring atoms. Ito daw po yung lattice structure of silicon. So let's define first the covalent band. Covalent band is a sharing of electron pair between two atoms. Yung silicon daw nagpe-perform siya ng covalent bonding with four of its neighboring atom. The valence electron of silicon is 4. So para mas maliwanagan tayo sa discussion natin, here is the graphic photo of the silicon with the sunlight from sun. So when the photons coming from the sunlight, it is struck the last shell and it will knock an electron of its orbit. That particular electron that's been knocked out of the orbit will circulate the system. It will transfer from one atom to another, kung saan na-achieve na natin ang characteristic ng conductor, kung saan dito na rin nagsisimula yung photovoltaic effect. Kumbaga, anong bang nangyayari sa solar panel natin? Yung mga atom ng silicon, pag tinamaan ng sikat ng araw, yung apat na valence electron, one of it is being knocked out by the photons coming from the sunlight. Another thing that is needed to achieve by the silicon semiconductor is for it to exhibit the characteristic of a battery. Di ba kanina na-achieve na ng silicon yung characteristic ng conductor, kung saan yung nagkakaroon na tayo ng photovoltaic effect, kung saan pag tinamaan ng sikat ng araw yung 4 valence electron, yung particular electron will move random. So, ano nga ba yung characteristic ng battery na kailangan natin ma-achieve or kailangan ma-achieve ng silicon? So, yung battery daw, meron siyang imbalance of charge on both sides. Therefore, two sides should be created, the so-called PN junction. Di ba yung battery, meron daw siyang positive side and negative side. So, sa positive, pinatawag natin itong protons and negative is the electrons. Pero sinasabi dito na pure silicon is not enough to achieve this. So, yung pure silicon daw kanina ay hindi sapat yan para ma-achieve yung imbalance of charge. Kailangan natin gawin is the doping. So, ano nga ba yung doping? Doping is the addition of other substance in a semiconductor for the purpose of modifying its electricity conductivity. Di ba nga kanina na-achieve na natin yung characteristic ng conductor, kung saan yung particular electrons move in random. So, ang dapat ma-achieve ngayon ng silicon ay magdagdag ng another substance to the both sides, the positive and negative charge nga. Di ba sabi dito, doping is the addition of other substance. So, in order to create an imbalanced charge of both sides, dapat yung isang side ma-justify and need an excess proton. So, dito sinasabi na para magkaroon ka ng positive charge, kailangan mo ng excess proton. Para naman sa negative side, kailangan mo ng excess na negative electron. And pure silicon cannot do that. So, kaya nga kailangan natin ng doping. Saan ang doping? Ay pag-a-add ng substance sa ating silicon. So, ano nga ba yung mga substance na dapat natin i-add sa silicon? So now, looking back to our periodic table, we should have higher number of electron to have a negative side of the silicon junction. So, di ba ito yung mga valence electron? Yung valence electron number 1, 2, 3, 4, 5, 6, 7, 8, so on and so forth. Kung saan yung silicon is pang number 14. So, sinasabi dito, for us to produce negative junction, kailangan natin ng substance na mas maraming electron. Pero dapat piliin natin yung pinakamalapit sa silicon. So, kung titingnan natin yung periodic table, ito yung silicon. So, ano nga ba yung mas malaki yung number of electron na katabi ng silicon? Ito yung phosphorus. So, next naman, para naman sa positive sides, kailangan daw naman natin ng isang substance with less electron to produce positive side. So, pero dapat piliin pa rin natin yung pinakamalapit na substance. At the same time, same yung characteristic nito. So, kung titignan natin dito, pwede yung aluminum. But, kung titignan nyo yung characteristic nito, iba si aluminum. So, kailangan natin maghanap ng less electron with the same characteristic, which is the boron. So, now, here is another question. What substance should be used as dopant for the silicon to become negatively charged? And what substance should be used as dopant for the silicon to become positively charged? Okay, balik ulit tayo sa periodic table. Phosphorus is the substance to be used as dopant for silicon to become negatively charged. And boron naman is the substance to be used as dopant for the silicon to become positively charged. On the n-type is phosphorus is being used as the doping materials, while on the p-type side, it's boron. So, sinabi na nga natin kanina, yung sa negative sides, kailangan natin ng phosphorus. Sa positive side, kailangan natin ng boron. So, another question now is, why phosphorus is the one being used as dopant to create the n-type side and boron to create the p-type side? Di ba kanina nasagot na natin ito? So, para mas maliwanagan tayo sa explanation, this is the answer. The silicon can be doped with atoms which contain more electrons to create negatively charged silicon, or with atoms which contain less electrons to create positively charged silicon. So, di ba nga, para makapag-create tayo ng negatively charged, kailangan natin ng more electrons. And pag naman kailangan natin mag-form ng positively charged, kailangan natin ng less electron.
Doon naman tayo sa may lattice structure of silicon with phosphorus as dopant. So, pag ginamit natin dopant with phosphorus, nasa negative side siya kasi may 5 valence electrons yung phosphorus. So, may maiiwang isang electron. So, magpo-form siya ng covalent bond sa 4 na silicon neighboring atom. Ngayon, may maiiwang isang electron. At yung tinatawag na loose-bound electron. So, yung naiiwang electron o yung loose-bound electron, magiging free to move siya within the system, transferring from one atom to another. Take note, mangyayari ito without the presence of sunlight. Next is the lattice structure of silicon with boron as dopant. So, kung kanina sa phosphorus may isang sobrang valence electrons, dito naman may kulang na isa. Bakit? Kasi 3 valence electron lang yung boron. So, 3 covalent bond lang yung mo-form. May isang kulang. Kasi, merong 4 na valence electron yung silicon. So, kulang ng isa. So, mapapansin natin dito na yung kulang na isang electron is magkakaroon siya ng hole. At pag kulang siya ng electrons, magiging positively charged siya. So, sa lattice structure of PN junction in a solar panel, Pag N-type, may sobrang electron. Pag P-type naman, may missing na electron kaya nagkakaroon ng hole. Ngayon, pag pinagdikit natin yung N-type at yung P-type, magkakaroon ng rush of electrons. Yung sobrang electron sa N-type, mapupunta sa P-type kasi P2 move sila. So mapapansin natin dito, yung sobrang electrons dito, mapupunta sa hole. Ngayon, nangyari yan, so yung sobrang electrons dito kanina, magta-transfer siya dito. So magkakaroon siya ng electrons. Ang mangyayari, magiging negative siya. So dito naman, nawalan siya ng electrons, kaya positive siya. Since there is the rush of electron from the N side towards the P side, the charge of the two sides will be reversed, making the boron dope P side become slightly negative and the phosphorus dope N side slightly positive.
We can see here that the depletion region is in the middle of PN junction. So, this rush of electrons will quickly form a barrier between the two sides called the depletion region. In here equilibrium is being reached, the electron stops flowing. An electric field is definitely created. The silicon is now exhibiting a characteristics of a battery. So, in this figure, we can see the electron-hole pair generation. So, due to the presence of electric field in the depletion region, those free electrons and holes will go back to their origin, which free electrons will go to N side and holes go to P side. So, sunlight enters the N-type side, then penetrates the depletion region. This process knocks an electron out of the band as many as it can, creating a pair of free electron and holes in the depletion region. The electric field drives the pair out of the depletion region. The free electron goes into the N side and holes in the P type, resulting in higher concentration of both. So, we can see here that those free electrons in N side will go to P side continuously. So we can see here that the top layer, which is the N-type, is thin and heavily doped, while the bottom is the P side, which is thick and lightly doped. So in this figure, the depletion region, that free electron and hole pair is being generated in a wider area, which it turns to produce more electricity. So, this is what I mean on those figure.
We already discussed how solar panel works inside the photovoltaic power station. As you can see, this is the power plant. The sunlight hits the solar panel na kung saan na-discuss natin yung solar panel kung paano siya nag-generate or nagpo-produce ng electricity. And remember that solar panel produce a DC electricity. And gagamit tayo ng inverter to produce an AC electricity. Sa AC electricity naman, gagamit tayo ng AC devices such as AC service panel, AC utility meter, for AC monitoring devices and regulator. So after nito is magi-step up transformer. Kung saan yung step up transformer, nagpe-prevent siya ng further loss due to long transmission line. And usually, the system become step up depends on the rating. So sa Pilipinas, gumagamit tayo ng 30,800 volts and it will be connected to substation. And yung substation na yon, magsusupply siya sa power utility. And yung power utility, yun yung magsusupply sa bahay-bahay. So tandaan natin itong utility ay ginagamit siya ng grid or the utility grid. So para mas maunawaan at mabilis ating matandaan, sunlight strike the solar panel, gives DC electricity. Gagamit tayo ng inverter. Magta-transfer siya as AC electricity. Gagamit tayo ng AC service panel and AC monitoring for the sake of regulating and monitoring. Tapos magi-step up siya sa transformer and magbibigay siya ng supply sa ating power utility. And yung power utility, magbibigay ng supply ng kuryente sa ating bahay-bahay. So para mas maintindihan pa natin ang explanation, basahin natin how do PV power plant work. Step-up transformer are required to boost the 480 to 690 volt output voltage to the 13.8 kilovolts and 246 kilovolts of the medium voltage utility network. It is then connected to a substation for distribution into residential area. When installed at a site, solar modules are wired together in series to form strings. Strings of modules are connected in parallel when necessary to form an array. In traditional PV plants, single centralized provides the voltage conversion. We already discussed the types of solar power plant. The first one is the photovoltaic plants. And now, we will go for solar thermal system, also called CSP. Let's read what is solar thermal system. Solar thermal power plants utilize energy from the sun to heat a fluid to a high temperature. These fluids then transfer its heat, which then becomes superheated steam. This steam is then used to turn turbines in a power plant, and this mechanical energy is converted into electricity by a generator. So dito yung solar thermal plants, ginagamit niya utilize niya energy from the sun to heat up fluids with a high temperature. So, pagkatapos ma-heat nito yung fluid, transfer nito yung heat sa water naman. Kung saan yung water, pag na-heat, magkakaroon to ng steam, which becomes superheated steam. And yung steam na yon, siya naman yung mag-turn to a turbines in a power plant, kung saan magkakaroon ka ng mechanical energy, which can generate an electricity. This system uses solar collectors, particularly mirrors, to concentrate the sun's rays on one point to achieve appropriately high temperature. So, this is the types of a solar thermal system. There are 4 types of solar thermal system. The parabolic draw, solar tower, linear Fresnel reflector, parabolic dish. Isa-isay natin to i-discuss mamaya. So, dito sabi, note, despite there are several different types, STS operates at the same principle. Refer on the previous slide, they differ only in the manner of collecting sunlight and concentrating it to a certain point. So, balik tayo sa una. Dito, sinasabi ng this system use solar collectors, particularly mirrors. So, di ba sabi, yung STS system daw, halos pare-pares lang ng operate. Pero nagkakaiba lang siya sa solar collectors, particularly yung mirrors. Now, let's define parabolic draw. This draw, also known as line focus collection, are lined up in rows on solar field and are composed of a long parabolic shaped reflector that concentrate incidental sunlight on a pipe that runs down at the middle of the draw. The collectors sometimes utilize a single axis solar tracking system to track the sun across the sky as it moves from east to west to ensure that there is always maximum solar energy incident on the mirrors. The receiver pipe in the center can reach temperature upward of 400 degrees Celsius as the draw focuses sun at 30 to 100 times its normal intensity. So dito, yung mga dapat natin tandaan is yung parabolic draw daw ay mas kilalang as line focus collection. Sinasabi din dito yung long parabolic shape reflector. Mamaya ipapakita ko sa inyo yung ano ba yung parabolic draw natin. So dito tandaan sabing yung receiver pipe can reach at temperature of 400 degrees Celsius and it can amplify at 30 to 100 times. So this is the parabolic draw. Kung mapapansin nyo, itong pa-curve na to or the parabolic segment is made up by mirror, kung saan yung sunlight nito tatama dito at i-redirect nito sa tube, kung saan yung tube na to merong tayong tinatawag na heat transfer fluid, saan i-discuss natin mamaya. So this is the wide range captured of parabolic draw. This is the closer view naman, saan uli magtatama yung sinag ng araw, i-redirect ng parabolic mirrors sa ating tubes. So this is the parts of parabolic draw. Saan ito yung parabolic segment natin or yung mirror, saan tatama yung sunlight dito ire-redirect niya sa ating tube. Kung saan yung tube natin, yung outside niya is cold glass, saan meron kang vacuum, the inner layer, and next naman dito yung fluids, kung saan yung fluids, ito yung tinatawag na heat fluids. So this is the diagram of parabolic draw and how parabolic draw produce an electricity. So kung mapapansin nyo, meron tayong sinag ng araw na tatamaan or kukuhanin or i-reflect ng ating parabolic segment sa ating 1, 2, 3, 4, 5 tubes. Kung saan yung 5 tubes natin ito ay heated by at 400 degrees Celsius. Pagkatapos, pupunta siya sa ating heat exchanger kung saan nandun ang ating fluid. So, now, yung pinainit na fluid with a 400 degrees Celsius is enough to turn that water into steam. Kung saan, yung steam na to aakyat dito, pupunta sa ating steam turbine, and then pupunta sa ating generator to produce electricity. Kung saan gagamit ka ng step-up transformer to grid and to community na. So, bakit nga ba tayo gumagamit ng step-up transformer? Diba sinabi natin kanina, it used to avoid the further losses of voltages because of very long transmission. So, kung mapapansin nyo, dito, may steam tayong pumasok. And dito rin, sa pababa ng ating tube, mayroon tayong nagaganap na condensation. So, ano nga ba yung condensation? The condensation is the process where the water vapor becomes liquid. Diba ito yung water vapor natin kung saan meron tayong condensation tower dito at heat exchanging condenser. So, bababa ito at gagamit tayo dito ng pump para mabalik siya sa ating steam boiler. Hanggang sa mag-circulate ulit siya, so on and so forth. So, this is the internal parts of parabolic draw. Saan meron kang central pipe or the tube 1, the parabolic shape reflective draw, the reflective coating or mirrors, the rational axis, the collector supports, and the fluid in and the fluid out. So now, may pagkakahawig to kanina sa ating unang diagram ng parabolic draw. But dito, kung mapapansin nyo, meron tayong hot salt tank at cold salt tank. So bakit nga ba meron tayong salt tank dito or yung molten salt? So tandaan natin, ang molten salt is one type of heat transfer fluid being used with the system. Mamaya i-explain natin kung bakit tayo gumagamit ng salt tank. And this is the heat exchanger. Kung saan tandaan natin yung arrow, in, out. So this is the basic diagram of a heat exchanger. Kung saan the cooler before papasok dito. And then magiging hot na siya. Kung saan yung hot before naman, pag dumaan na siya dito, magiging cooler naman na. So again, this is the basic diagram of a heat exchanger. So now, how do heat exchanger operates? Kung mapapansin nyo, yung araw na to, ito ang ating heat exchanger. Kung saan dito naman, ito yung pinainitan ng ating tube with 400 degrees Celsius. And itong blue and red, ito yung ating fluids hanggang sa pinainit na. And this is the internal parts of a heat exchanger. The shell side, the shell, the tube side, and the shell side. Also the tube side. Tandaan natin itong tube bundle para mas ma-appreciate natin. Ito yung picture niya. Ito pa pala muna yung heat exchanger. And pag kinat-out natin itong heat exchanger, ito nating makikita ang tube bundle. The closer view of a tube bundle or an heat exchanger. And now, there are different types of turbine. And this figure is represent and designated for a steam turbine. And now, this is the video presentation of a parabolic draw and how parabolic draw produce and generate electricity. As you can see, this is the parabolic draw. You can see the parabolic segment, which is mirror, and the tube where the fluids is being heated. is the parabolic segment and the mirror and the tube. And when the sunlight hit the parabolic segment, it will redirect to the tube. And this tube will be heated at 400 degrees Celsius. And this is the fluid inside the tube. As you can see, the fluid runs to the tube, is now being heated and go to the heat exchanger kung saan nandito na yung water natin, and ito yung makikita nyo ang steam kung saan siya ang papatakbo ng ating steam turbines, and dito ang ating generator which produce electricity in our community. So to sum up the video, gamitin natin ulit yung parabolic draw diagram kung saan meron tayong parabolic draw kung saan yung mirror nito, nire-reflect niya yung sunlight sa ating tube kung saan i-heat nito yung fluid with a 400 degrees Celsius, and yung pupunta na siya sa heat exchanger kung saan yung water natin i-heat niya and magkakaroon na ng steam. And the superheated steam, it turns to a steam turbine, and yung steam turbine na yun dediretso sa generator which can produce electricity, and gagamit siya ng step-up transformer to grid and to community. So, para mas maintindihan natin ang parabolic draw, ito yung point by point ng ating parabolic draw. Heat from the sun is being collected by a special mirror which is then reflected to the pipe that runs down the middle of the draw. Yung sinag ng araw ay kinokollect ng ating mirrors which then reflected pipe that runs down in the middle of the draw. Within the center pipe is a heat transfer fluid called the HTF. Diba yung HTF natin? Yun yung inside our tube. Flowing inside it, the HTF inside the pipe can reach a temperature of 400 degrees Celsius as draw focuses sun at 30 to 100 times its normal intensity. These hot fluids goes to a heat exchanger where the heat is transferred to water, generating high pressures superheated steam. Yung pinainit na fluid, na-transfer nito yung heat sa ating fluid kung saan magkakaroon tayo ng superheated steam. This steam then moves a turbine to power generator and produce electricity. So, pag nag-produce na ng steam, magdadaan ito sa steam turbine at makakapag-produce and generate na ito ng electricity. The HTP then keeps circulating within the system, and the HTP nga magsisirculate na para maulit-ulit yung process. The steam is being condensed which is sent to be back through the heat exchangers.
In a solar thermal system, heat transfer fluid or HTF is a liquid or a gas specifically manufactured for the purpose of transmitting heat from one system to another. So yung heat transfer fluid, ito yung liquid or gas na nasa loob ng tube na ginagamit para mag-transmit ang heat. So why use HTF instead of the direct system in which water is instantly turned into steam by the heat reflected by mirrors in solar thermal system or CST? So bakit kailangan natin yung HTF? Na siyang iinitin natin, tapos yung HTF na yun, tsaka pa lang natin itatransfer heat sa water para makapag-produce ng steam. So bakit na lang hindi natin indirect na ilagay yung water sa tube na siyang iinitin natin para makapag-produce ng steam? These working fluids have high heat capacity. It can maintain a high level of hotness in a long period of time. That is why in CST, large volume of HTF is heated to an elevated temperature during daytime where sunlight intensity is at its peak. Then it's being stored in a tight vessel. It acts as a reserve power that can be used during cloudy days when the sun intensity is at its lowest, or during nighttime where is totally no presence of sunlight. So ginagamit natin yung HTF kasi meron silang high heat capacity na kaya i-maintain yung high level of hotness in a long period of time. So para pag cloudy days na mahina yung sikat ng araw o kaya sa gabi na wala talagang sunlight, pwede natin gamitin to as a reserve power. So here are the types of HTF: air, water, molten salts, glycol-based, glycerol-based, and synthetic oils. So yung air and water, sila yung HTF na hindi na-i-store. Samantalang yung molten salts, glycol-based, glycerol-based, and synthetic oils, sila yung pwede mong ma-reserve. The following characteristics are being considered on what type of HTF is to be used in a solar thermal power plant. So first is yung operating temperature. Ito yung limit ng temperature. The next is yung type cycle, kung gaano ba katagal. Heat transfer capability, heat storage aspect, kung gaano katagal siya i-store. Then overall safety, so pag dinry ba siya, pwede ba siyang expose sa environment. And cost, yung halaga. So ito yung kino-consider natin para malaman natin yung proper HTF that suits on their operation. The use of molten salt in parabolic fluid system can heat the heat transfer fluid to 550 degrees Celsius, has better performance than a synthetic oil which can heat the HTF to only 500 degrees Celsius or less. Doon naman tayo sa may parabolic dish. This consists of sets of flat mirrors combined to form a large parabolic dishes that is attached to a motor sensor which automatically tracks the movement of the sun. The collected energy from the sun is being concentrated to the PCU located at the focal point of the dish. The PCU consists mainly of thermal receiver and streaming engine. The thermal receiver, which is a heat exchanger, transferred its heat to the streaming engine, causing it to reciprocate. This reciprocating movement causes the rotation of an electric generator. These dishes can concentrate sunlight much better than parabolic fuse, and the fluid run through them can reach temperatures upward of 750 degrees Celsius. Because of the limitations of size and the small quantity of fluid, parabolic dish collectors are suitable for small-scale power generation up to few kilowatts. Stirling engine. Stirling engines can be hard to understand. Here are the key points. Every stirling engine has a sealed cylinder with one part hot and the other cold. The working gas inside the engine, which is often air, helium, or hydrogen, is moved by a mechanism from the hot side to the cold side. When the gas is on the hot side, it expands and pushes up on a piston. When it moves to the cold side, it contracts. So this is the parabolic dish, and this is the PCU, which consists of thermal receiver and stirling engine. So this is how parabolic dish operates. So the sunlight being collected with the sets of mirrors are reflected directly towards the PCU, which consists of thermal receiver. The heat that the thermal receiver received will transfer to the stirling engine and it will reciprocate. So this is how stirling engine works. So this reciprocating movement is being coupled in a generator. So there's a gears which will transfer the reciprocating movements into rotational movement. So the reciprocating movement is being coupled in a generator which generates the electricity.
The HTF here is being heated at around 600 degrees Celsius. A solar power tower system uses a large field of flat, sun-tracking mirrors called heliostats to reflect and concentrate sunlight onto a receiver on the top of a tower, and it contains a tube. So, a solar power system uses a large field of flat, sun-tracking mirror called heliostats to reflect and concentrate sunlight onto a receiver on the top of a tower, and it contains a tube, goes to heat exchanger, and after to the steam will go to the turbine. Then the steam will be cooled down and turned back into form of liquid, and after to the condenser, it will pump again and go to the heat exchanger. It is also the same, but we have a detailed picture which is the 3D. Next is the linear Fresnel reflector. This uses flat mirrors and it has a receiver in the form of horizontal tube. The sunlight will be reflected into the secondary reflector through the RA mirrors that located to the ground, and this tube contains the heat transfer fluid and will go to the heat exchanger, and it's the same process before. So in this picture, the different only is the manner of collecting sunlight because the tube is located above. So this is also example of linear Fresnel reflector. So we have here a tube which is the central receiver that contains heat transfer fluid. Also, these are another diagram of compact linear Fresnel reflector. But there are two absorber. We have two receiver which become more efficient to collect energy coming from the sun and transmit it into the tube. It is also the same but different in manner in collecting sunlight. So these are the largest thermal power stations. We have here the Quarzasate solar power station which has 510 megawatts in Morocco, and the type is parabolic grow and solar tower. So the next is 392 megawatts in USA, and the type is solar tower, and the rest is parabolic grow. So this is what it looks like, the Quarzasate solar power station. So this one will be the highest in terms of megawatts, and the combination of parabolic grow and solar tower, but is still under construction, and the expected completion date is 2022 and located in Dubai, UAE. So this is the name.
So that's all for today. And sana marami kayong natutunan and thank you. God bless.